Löwe schleicht vom Sumpf herauf, auch er will heute Nacht wie ich bei dir zu Hause sein. Er hat das Bett gemacht, das bleiche Tuch ist nass und kalt, wir liegen tief im Tau. Ich sterb ein Stück in deinem Arm bis tief ins Morgengrau. Maria, komm her, diese Stunde wiegt 2000 Jahre schwer. Maria, komm her, diese Stunde wiegt 2000 Jahre schwer. Maria, ich fühl dein Blut, wie's heiß und laut durch deine Adern rinnt. Wir küssen uns die Lippen wund, verloren wie wir sind. Dein schwarzes Haar, es legt sich mir wie Efeu um den Hals. Ich trinke wie im Fieber von deiner Haut das Salz. Maria, komm her, diese Stunde wiegt 2000 Jahre schwer. Maria, komm her, diese Stunde wiegt 2000 Jahre schwer. Maria, komm her.
Good evening and welcome back to our attempts at writing a terminal emulator on the TIS-100, where I appear to have written a lot of code that doesn't actually do anything. Well, it does. So, yes, and I left myself at least some notes in the comments, apparently. Here's my birthday bank holiday. That's entertaining.
Coronation thing, yes. Well, your birthday is the 11th of May, at which point I realise it's the 8th of May every year.
Right. So.
You can also hear me bittering and complaining about my core game in the background.
Sorry, yes, I'm going, So, yes. Surely that should be MOV9, right? Or am I confused about what MOV... Oh, right, no, it's... Hang on. Oh, no, 4 and 9 are right the top half and bottom half of a character. And 1 is moved to this line on the screen. Isn't it? Yes. You start a new line with... at this point on the screen.
Something, isn't it?
Technically,
That's something,
the 16th, yes.
So,
So I missed the start of this. What are all those strange symbols? Is there a translation table somewhere that says what they...
no, but there's a set of input and what the output should be, from which you can infer the translation table. There is an our translation table. It's written in this comment here. We are told that 0 is the new line character. And the only other characters we see are 1, 2, 3, and 4, which I have drawn in hashes in the in that comment, that set of comments. Those are then encoded in those two processors. One of them encodes the top row, and one of them encodes the bottom row, and you can thus pass to this processor instructions that are go to the start of this line, render the top half of this character, render the bottom half of this character, and end of line. So then the idea is that we've got these 6 nodes here in which we organise turning the incoming character stream into a series of those instructions, which will probably involve using the stack memory nodes to store the entire line so that we can draw the line, write the line twice. So yes. Okay. So this one currently just splits copies the incoming character stream into that stack memory node and down into there. And I has a note on what else I might want to do with it. Presumably it could then insert. Well, yes, it should treat. It should be the thing that handles what happens on new line. Except that would involve bouncing things, keeping the character position stored in back. So I think we want actually to use ACK in this processor to store the current character position instead. Does this one use its accumulator? It doesn't. But it doesn't have any spare registers. I was just thinking something needs to keep the line counter. But much though I'd like to keep it in here, I don't have any spare registers in here to keep it. So it'll probably have to be kept in this. Don't have any spare instructions in here to process it. So it'll probably have to be processed over here. So if we say that this processor keeps the current column position in its accumulator, which will probably not be like the real column position, it'll be the number of characters. Not that it matters, because like add 1 costs the same as add 3 anyway. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it doesn't keep the current column position, it keeps 10 minus the current column position, because that way we can decrement it towards 0.
I'm not in the context here, I just saw that in my comment.
There's an Assenbrook program on earlier contained authors, which we should probably look on iPlayer at some point.
So, now we go. We do also need to check whether we've just got an explicit new line, don't we? And that's kind of inconvenient. So wherever we are, we're going to need to be able to load characters into ACK in order to check whether they're an explicit new line and have a counter of where we are on the screen, I fear. So maybe I do just want to do all of this up here. suppose at this point we no longer care about the thing we've got in ACK, except insofar as it might be a new line. So we could loop back to there in the case when we haven't found we have a new line, when we haven't reached the end of the line, and then otherwise we end up down here and we then need to do something on a new line. Who knows what. So we could test that actually. Let's go mov right nil. So that'll just stall. Have this processor just absorb data for now.
You wish you could say move up debug. And then you'd get some record of what it was absorbing. Somewhere where it wouldn't otherwise cause.
Yes. I mean, actually, let's just hit run. And it stops having correctly got precisely one line of data. Good. We're probably going to need some kind of a sentinel, aren't we? So that we can then copy the contents of this stack onto that stack so that we get it in the correct order again. Because, yeah, we're not going to have any convenient knowledge of precisely how many items we've stuffed on there unless we... Well, I suppose we do kind of know, because it's whatever the value of back is at the point when we reach here. Well, rather 10 minus whatever the value of back is when we reach here. So we could probably have what new line does be send some indication of the correct amount of data to copy. And that will save mucking around with sentinel values, which will probably make things faster. So we could have that go... I mean, there's a slight problem, of course, that we're already using signalling down to this for another purpose. So we can't just send some special value unless we start... How about we send so if we go swoop neg, I mean, it might be 0, but that's not actually a problem because zeros can't otherwise get through here. I mean, we might want to do something more complicated, but so then essentially it sends, because we've reached the end of the line, it sends a 0, but it would then send minus something. So we could then have this do something like obviously at the moment that's just throwing all of the data away unless it's an end of line marker. And that works correctly. So now we can probably remove that. And then We could then pull that into here. It's currently minus the number of characters of spare spaces on the line. We want to convert that into the number of things that we want to copy, which I think is just a case of adding 10 to it. I mean, we could stick that add 10 in here instead, but let's this processor is going to be doing almost nothing, so let's have it do the hard work there. So I think that's all this one does for copying downwards. That didn't work. This one needs to stall, of course, while that's being emptied, doesn't it? Right, so the first line then goes, and obviously now we need to make more stalls happen, but
But the first line got copied in there, and then the reading process resumed, and then
yes,
the second line into the top stack memory node, and
then it just got, yes, blatted back down again. Let's, for now, have this one stall at this point then. Just so that I can make sure that otherwise it looks reasonable. Right, so we do have a bug here that explicit new line got copied into this node, which we don't want. So that needs fixing. That's actually easy enough to do, isn't it? I think that's just a case of moving that. No, moving that line to... Actually, no, moving... What? Moving... I'm getting confused here. Moving both of those two lines below the test so that we, when we receive a new line, we don't do anything with the data, because this will be the signal that we've reached a new line. Right, so that looks good. So our first line, in the order in which we read it, will be 3, 4, 4, 4, 4, 2, 2, 4, 2, 2. Yes. It's confusing because I really don't know which way up a stack should go now. Well, I want these stacks to push down, except of course the top of the stack is the thing that on here is the top of the stack. So obviously they don't push down. I have a horrible feeling that I think that stacks have two tops and no bottoms. Because I think I have a horrible feeling that also the end of the stack that you add things to and remove things from is the top of the stack. And that this, yes, is ultimately because... Well, probably because the VAX has it stacked that way around. I don't know. As in, you push things onto the stack by decreasing the address of the stack pointer. Right. Anyway, so that's all looking good. So now we've successfully sorted out getting our data into the right place. So now I think we need to start working out what this processor, which actually converts character data into something that can be operated on, should do. So let's just change that to go mov to send a copy downwards. So that means that this one does get to see the new line signals because it needs to know, it needs to do something with them. That suggests we want to move that add 10 into a different... Oh no, but then it'll end up not being negative, which is difficult. Hello, Eek. Yes, you may make a tapping noise if you want. Your nose is not damp enough to operate the touchscreen happily.
Very excited.
Yes, I appreciate the rabats. So... No, let's do some of this. Right, so, how do we do this? So if it's greater than 0, then it's an ordinary character. Yeah, this one may actually... This one will probably benefit from having an explicit new line character at the bottom of the stack, won't it? Or top of the stack, I don't know.
Probably not the middle.
Yes. But given that it has a character, for the top half, it should, let's call it T top. It should just do, or actually wants to start with a start of line. Then displaying the top half of a character should be done by if, however, we receive a character that's 0 or less, we want to essentially cause a new line, which is we send an end of line this is getting quite verbose, isn't it? We haven't even written the code to do the bottom half of the character yet. Right. This is going to have to be cleverer. So I'm wondering if we can do this essentially starting like that with a JRO of things that we're provided with from up here, and have this one do a lot more of the control. So for instance, the first byte of each character, this one, we could have it explicitly say, let's see, we need so we could have something like that, and then instead of mov act down, it could be mov 1 down, mov act down, But then we do need to have some kind of initialization. Well, I suppose that can just be stuck in at the top for now, can't it? This, of course, has the advantage we don't have to swoop so much if we never actually load the characters into the accumulator. So that might well now correctly render the top row. We'll probably want some kind of end of line handling as well. But admittedly,
Easy.
You could just look at Simon.
No.
Okay, you did even worse at that than I thought I was going to do. Yes.
well, that's catastrophically wrong.
Your drink.
I actually hit Simon's drink. I was in no way aiming, but I would just like to point that out.
Really, very catastrophically wrong.
Well, Simon can actually throw things, including stones, unlike me.
It's true, I can't throw you. Or at least if I did, my jugglings could prevail with nothing.
I don't mean MOV 0 right, you idiot. MOV 1 right. Okay, that's still not correct. No, we do actually have to signal that we want to do something. Want it to do something with U character. Right, so that looks like that's correctly rendered the top line of the top half of the first line of text.
Very plausible, yes.
Good. And we've still got some spare code space to do the rest, maybe. So once we've done the top line, then that's always going to be followed by a bottom line, isn't it? Which is interesting. So you could just stick in another separate jump table down here that does the next bit, because I think that will probably save us a jump. I mean, otherwise we end up having to put a jump instruction here to take us back up to that JRO up. May as well have another one.
Hold on. I think it's been cycling back the top per character.
Yes, but while printing the top row of the
Right, but if you
table.
put another jump table in, then it'll interleave the top and bottom halves of each character. Or is that the only?
No, because the second jump table will only be entered when we've reached the end of the line. But I'm not sure I'm not sure if that's what we actually want.
Second jump table, but the same JRO.
Well, it may as well be a different JRO. It doesn't really matter. Either we jump back to the first JRO or we stick in a new one.
Oh right, yes.
I think, and I mean, actually, I think it doesn't matter because they're each one instruction. So there might be some use to this because we might be able to reuse the same numbers entertainingly. So or maybe, I don't know, we'll worry about it in a bit. So that's then an instruction to copy something out of the stack memory node in order to process it. And then we can have this one handle the counting, because it conveniently at end of line, well, we need it to do a start of line sequence first, don't we? Yeah, maybe we should just have a single JRO. I think that will make my life slightly less confusing. So that actually means we want, so mod 14 write is end of line. So then we also want to do a start of line sequence, which actually is add 1 jump right to the top of the program. Obviously we can avoid that jump by making that the last case. But then we need, well, I suppose we could just assume that it's going to be right at the end of the thing, can't we? Presume if I do that we get the right behaviour. Except we don't need that jump at the end, that was the whole point. So then that adds 1 and then falls through into the start of line procedure, which is probably what we want. So that's right top half of the character, and then 2, 3, 4. Then this will be right bottom half of a character, which it does by copying out of there. So now we just need this one to work out what on earth it's doing about that. So ACK at this point contains the thing which, if you add 10 to it, is the number of operations we need. So let's add 10, and then I just realised I've encoded a bunch of assumptions that you never have a line with 0 characters on it. I kind of feel that banning successive new lines is probably a bit vicious, but let's see if any of the test cases include successive new lines. So then it should send a 4 sub 1 JNZ B for bottom. So that then sends all of the bottom halves of the characters in a loop, and then we need to send 2 go to the start of the next line instructions in order to skip the blank line at the bottom, and then we go back. Then possibly we go back to the start. It might work. Okay, let's see what that does. So that's an interesting failure. So we've ended up with those two. That's doing a JRO ACK to 0, which feels unfortunate. So it starts out all right, doesn't it? We successfully draw in the top line.
I should work out whether we can tighten up the chassis or nail sticks to it or something to stop it dropping its power cable at Stitch's provocation.
Glue in a tube to it.
Hmm?
Glue in a tube to it.
We were thinking of gluing Velcro to it, but I can't think how to do this because I'm mechanically not very, especially not very anything.
So at this point, the thing on the left is now copying stuff. The thing on the right, this thing has seized up actually. Something went wrong. And this shouldn't be stalled writing to the output processor, should it? The output processor thinks it's processing a 4. But it isn't meant to be processing a 4 at this point. It's meant to have just processed a 14 and be waiting for the next bit of data. Actually, no, it's meant to be yes, it's meant to have just processed a 14 and be about to process a 1. Okay, so that went wrong slightly before then. So that bit was all fine. This is writing out another 4. That's wrong. Because it's about to receive a 0, and it shouldn't pass zeros through. Ah, have we got a spurious MOV? Yes, we send things down even when they might turn out to be zeros, and it's quite important that we not do that. Let's move that up to there. Okay, that doesn't work at all, because that JGZ is actually where all the good stuff happens. Hang on, no, that JGZ just takes us back to the top of the loop. We're yes, our problem is that we currently unconditionally send data downwards, and we can't safely do that. So we need instead to have that JGZ go to somewhere where we actually process a character. And then so we should
Every processor here is chock full.
so that then we jump down there if it's an ordinary character, and if it's not an ordinary character then we execute that bit. We don't need that jump L because that's the end. L is the top of the program anyway. Well, that was a good start, but it doesn't work. Right, let's watch that in a bit more detail. So the first line still gets output correctly. We have, I think, also output a new line sequence, but maybe I should actually watch that happen. So there, we're now outputting the start of a new line. Did we, hang on, let me just breakpoint at the point when we should be signalling the end of line and make sure that happens. Is that how you write a breakpoint, or do you actually have to, was it, no. Okay, do we actually, we do.
I've not seen this usage before. Do new lines in this, do the blank lines in a processor count as instructions for JR and offset purposes?
I don't know that I know, actually. Let's find out. No. Because that just jumped to the last instruction in the processor rather than the second to last. In these ones, I actually put in a NOP because I wasn't certain. But it does appear that blank lines don't count. On the other hand, in these cases, we can perfectly well make that a 7 in order to avoid the issue. Whereas in these, we're actually using like character codes to do the jumping. Okay, so let's try that instead. Okay, that looks better, but we've somehow stalled. Oh, have we just hit that? We've just hit that breakpoint, right? I don't need that breakpoint anymore. I fixed the problem. Well, that's an odd place. Oh, right, we've crashed at the first explicit new line, I think.
Well, I suppose a reasonable thing.
So let's walk through what happens when we get to one of those. Okay, I think I'm slightly late. Let's do that again. Oh, maybe I was slightly late. Right, so there's our new line about to be. Yes.
You might be able to put a breakpoint on input.
Yes. Right, so we've just loaded the explicit new line. So this processor then jumps straight to the new line handling code. It then slurps that 6 back out of back, turns it into -6, and sends it downwards. Various other things are still processing stuff. Right, now we get that 6 and send it leftwards.
But the left processor
Is currently crashed at mov left nil.
It's
Oh, right,
installed, in fact.
because I have that. It's not the first explicit new line, it's the end of the second line. Because I had this one stop at the end of the first line. So the only question is it safe just to let it go? Probably, yes. That looks better, yes.
There's a 1 character line, but not a 0 character.
Success! I'm slightly surprised to discover we're quite slow. I'm pretty sure I wrote a slower version of that last time I did it. Like, I think I had it actually render each character in sequence. So each character was render top line part, render bottom part.
Is that so bad? I mean, if you do that with a JRO.
Yeah. Well, yeah, you still need to like keep track of both the X and Y cursor positions,
Yeah.
which is what I've managed to avoid here. Oh, well, it worked.
Rosenberg.
And, like, I do quite like this implementation. Right. Well, let's have a go at the back reference reifier then. So we have another little bit of plot. We can only speculate what sort of world it is. If they have some ability to create quantum gates, but their computers are like TIS-100, perhaps they developed to a late 70s level of technology and somehow got access to devices beyond them. Another gate to their own world, maybe. We have to stop them, Randy. We have to stop them! Maybe. So, read a value from in.r. If 0, copy value from in.a to out. If -1, copy previous in.a value. If -2, copy second to last in.a value, and so on. Maximum number is -4, rather minimum number is -4. So note we don't get any stack memory nodes. So it's going to be necessary to stash all of the relevant numbers in registers of any convenient processors.
So I'm still struggling with this because the text is a little small. There seems to be as many in values in both columns.
Yes.
So if in B is in B is the control button, right?
In R is the control, but yes.
Sorry. If in R is naught, then you consume a number from A and write it as literal. If in R is less than naught, you consume a number from A anyway and drop it on the floor.
And remember it in case you're asked for it later.
Oh right. Oh right. You have to remember that. Right. Sorry. Yes, you're not writing the more recent thing that you output, like an LZ7070 code or something.
I don't think.
I mean, it'd be crap LZ77 decoder, but it only had a maximum run length of 1. But I suppose you might still find that useful for Huffman purposes. But right, yes, no.
It does say previous in.a value, not.
So you have to remember the whole input sequence. You don't know which of it you might be able to regurgitate.
Well, we know we only have to go back to -4, so
Yes.
like we don't have to remember very much. But yes,
But you're remembering the last form of the input sequence, not the last form of some subset.
yes. So. I'm now thinking that what I want to do is to have a couple of intermediate processors whose job is to replace each number in the input sequence with a run of 5 numbers from the input sequence. So we essentially output, assuming that our input was just an increasing sequence of integers for demonstration purposes, we would output something like 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 4, 3, 4, 5, 6, 7, etc. In that then we just need in each of those blocks to pick out the one that we want. and we can do that with a counter that just counts through each block. I mean, I'm not quite sure whether we go up or down at this point, but so we would do, if we want to do that, I kind of wonder if we have something that looks a bit like this do something useful. This is kind of not really that I'm writing necessarily code that I know is right, but it's the shape of code that I feel we might need. Well, let's see what that does. I think that's shifting by too many, isn't it? Does that then output 0, 0, 52, 80, 56, 98? No, that's completely useless. That's just outputting 2 zeros and then outputting the same data. That's no good at all. Because we need to output more stuff than we read in. Okay, let's do the simple one. Let's have something that outputs 1, 2, 2, 3, 3, 4. That's obviously trivial, actually, isn't it? That's okay. Maybe that wasn't an interesting place to start. And of course, actually, it has to output 0, 1, 1, 2, 2, 3. And our eventual one has to output 0, 0, 0, 0, 1. 0, 0, 0, 2, 1, 2, 0, 0, 1, 2, 3, 0, 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 5, etc. So then we see 0, 52, 52, 80, 80, 56, etc. Right. So that's the correct first stage. So can we then pipeline this, add an extra step to the pipeline? Well, it then wants to we then presumably need to use back for something. So obviously we have to start by doing something that causes us to write 2 zeros. So then that will write 0, swap 0, move that in 1. But then we need another swap, don't we? So then it will write 0, swap 1, 2. That's not quite right, I don't think, because we've got, let's just test it, because I think, so we start by writing a 0 and a 0 and the first value, which is 52. Then we write 0, 52, 80, but then we really want now to write 52, and we instead write 0 because we're missing another swoop somewhere, or possibly we've got too many swoops. So when did we accidentally throw away the 52? So we've got the 52 in ACK, we stuff the 52 into back, but then we need to stash it again here, don't we? So I think maybe that swap belongs there. So we send 0, 0, 52. No, that's wrong. Add another swap there instead. Because, yes, we probably want an odd number of swaps so that things advance through the system. 52. 52, 80, 52, 80, 56. Right, so that's got us some expansion. That expands into groups of 3, but we do need groups of 5, which probably means we can do the same thing here with caching of like the, so we need to cache the first 2 values of each group of 3. So no,
Stoked. Yeah.
so so
That just wouldn't fit in this house. Well, at what point they'd come out of it, and then we'd have even more problems with the door.
I might eat all the bench plus the creeps.
It's also true.
Pink Beast asks, I appreciate this may show just how little I'm following this, sorry, but why is the bottom left always communication failure debug? So the idea, the kind of underlying plot of the game is that you have a rather broken TIS-100, which you are trying to fix up the self-test routines for so that it actually works. And part of the problem is that some of the nodes are broken, and this turns out to be because people have been overwriting their microcode with little notes to themselves, or in extreme cases, somehow writing things into the microcode that allow them to communicate with other people in other times through their TIS-100. And so we have these occasional nodes, which should actually be in red, but you get to see them in green because you can't read red on black over MPEG, that give us little messages of ongoing plot.
But some of them just say communication failure, and it just means
Yes.
you can't use this node. It's awkwardly blocked.
Yes.
But the ones labelled debug also have plot messages in.
I can't use this node, it's awkwardly blocked.
So I think I just do something that looks very much like our first attempt, except it spawns, it moves 2 more copies around, except we add a couple of mov up downs to get the first 2 elements of the sequence, or possibly the last 2 elements, I'm not sure. So we get 0, 0, 0, 0, 52, that's a good start. 0, 0, no, that's wrong. Let's put that there instead and see if that works a bit closer. 0, 0, 0, 0, 52. 0, 0, 0, 52, 80. 0, 0, 52, 80, 56. 0, 52, 80, 56, 98. 52, 80, 56, 98, 32. Right, so that's now doing the stupid thing that I decided I wanted to do, which is it copies, converts the sequence into a sequence of groups of 5, where for each one we merely have to pick out the correct element. Now I'm
And the selector should be 4 discard instructions. Four instructions to mov up nil, 1 instruction to mov up down, 4 instructions to mov up nil, and then you can jump to the right. Oh no, you can't. That doesn't work. So you JRO to the right part, to the right number of spaces before the. But the trouble is you can't.
I'll keep running them after I fall off the end, sadly.
5 of them and then stop, which is less good. Shame. Oh, well.
I'm now burning quite a lot of processes just getting this number to where I want it, which is probably not ideal. Actually, maybe we just insert it at the start of each of those groups of eventually 5, or possibly at the end. I don't know. No, let's do the dumb version for now, and then we'll be clever. I'm just now wondering if I can do something really, really, really silly. No. Maybe. No. Oh, maybe. I'm wondering if I can just do something that essentially goes... oops. I don't think I can, because that will at some point send a 0, and obviously JRO 0 is an unhelpful thing to do. Because the thing is that by doing this, I can make that loop counter be like part of the be just the program counter, and so I don't have to carefully count up to 5 each time. But there's a slight problem that will pass a 0 at some point, and I have a horrible feeling I have a way I could avoid that. Like maybe if we multiply it up and offset it a bit. Because I was thinking what we could do. No, we need to multiply it a lot. Like, could we arrange that the JRO hugely negative number and JRO hugely positive number both caused us to discard a value, and JRO some number close to 0 caused us to process a value, to pass through a value. And then we could essentially multiply up our number by quite a bit and add some convenient offset. And then, as it shifted past, we would get the various things that we wanted to do. But the problem is that means that the first instruction in this processor needs to be discard something, and I don't really want it to be that, because we won't always want to discard the first item. We want always start up on this JRO, which needs to be somewhere in the middle, so you can jump both ways from it. And so I don't think this trick is going to work.
And then you can have a processor on the right. Feed that processor something at startup that it can discard safely.
Yeah, that doesn't quite work either. Actually, what we could do is put the silly unrolled loop here. Though actually I could now, it's now obvious that I could actually move all this one processor sideways. Why on earth am I doing this as a JRO when I can just put all of that? Yeah. Not everything has to be a JRO. We can just do that. And it all ceases up immediately. Because that says down, and down is not a helpful direction to move things in. Well, that's spectacularly wrong. I suspect that this means I've got everything backwards, haven't I? Yes. Because I'm counting 0 as being the earliest item in the sequence, whereas it's actually the most recent item in the sequence. How lazy can I be about this? That completely...
Less lazy than I was going to be. I was going to say neg sub 4. No, add 4, whatever.
Yes, in particular that doesn't work. What I just did doesn't work, whereas your one will work. I mean, I think we could probably do better by actually organising our data structure to match what we're being asked to do. And like, this is a stupidly inefficient approach, in a way, in several ways. But actually one interesting feature of it is it has very few branches, so it's probably quite efficient on a modern processor.
Modern processors have memory.
We only have 2 branch instructions in the entire program.
You don't even need memory. An Alpha XP could do this when it's right up at boot time and hasn't turned the RAM on yet and is running entirely out of cache.
Apparently this is a good solution as well.
I mean, it is possible to do it faster. You did think it was, and it is, but...
I mean, I am, as a matter of something, going to fix the order in which we process things, which involves rewriting these 2 backwards. So it should instead output 520000. So this one should output 5200. So it should go... It should start with mov up ac, mov ac down, and then actually this may turn out to be harder. Because that means that I have to store that 52, which I wasn't previously doing, I think. Because if I need to, I want to output 5200, then I would have to store the 50, then I need to save that 52 somewhere while processing both of those two zeros. But I don't have anywhere to, I don't have a third register to stick it in. Okay, actually doing that is more complicated. I mean, admittedly, we should probably remove that neg and turn those into turn that into add4 and turn those into sub1, because that at least is easy. I mean,
definitely moved off that peak.
I
mean, I think the lack of branches probably is helping.
yes, because they cost instructions, even if you don't have a branch prediction problem.
Although your instruction count seems to be remarkably good regardless of that.
Oh yeah, sorry, they cost cycles, possibly at the expense of giving you extra instructions. I'm slightly wondering, can we arrange not to need... I mean, we can arrange not to need that processor by shoveling the relevant data down through those ones, but we can't really get rid of this one. Because its program counter is providing the counter that this thing needs. So... yes, I don't think that can be made... well, actually, of course, it can. If we can... no, but the thing is, we can't interleave that, because we'd have to like put all 4 of those instructions in each of those unrolled loop iterations, which we don't have. Okay, no, I'll accept that that's probably as good as I'm going to get. Pretty good, anyway. Dynamic pattern detector.
That sounds scary.
Typical implementation is 8 nodes. They plan on taking our water, oil, trees, everything, siphon it back to their world through the gate. They've done it before and we're next. Randy, how do you know this? I can see them. I'm watching them right now. Oh no. What? This is bad. I think this means we're entangled too. Okay. Sequences are 0 terminated again. Read a pattern sequence from in.p. Read values from in.s. Write 1 when the pattern is found. If not true, write 0 instead. So our pattern is quite short. It's only 3 values. We have no stack nodes. So the length of pattern that we can read will affect the size of the program that we write. So let's assume for now that it's 3. Or at most 3, and then we'll discover if we need more later.
Can you run will it progress to further tests if it gets things wrong?
No. So we only get to see the second test case when we pass the first test case. So, and the general plan is, yes, that when we spot 2143, for instance, we write a 1 at the point that corresponds to the 3 in the input. And there's another 2143. And there's a 2144 there to keep us on our toes. So that means that we need to handle. And yes, there is a 21-21-4-3 just to make sure that we don't that we can handle restarting the sequence in the middle. I mean, I kind of feel that we might want to do a similar trick to what we did last time and expand the input into a set of 3 long subsequences. So essentially use the same code that we did last time, though maybe we'll need to route via some different processors. Though apparently the typical answer is 8. Oh, I can't see it from here apparently. So the 9 actually. I'm kind of wondering, are we going to need those 2 nodes? Probably not. So, so then, now we have a set of, oh, that's fine, of course, if our input sequence is precisely 3 long. If we start making it longer, then it gets more entertaining. Plus, we have to, like, store the input sequence somewhere. But ooh, I'm I'm having particularly evil thoughts now. Like, if our test cases are not very comprehensive, maybe I could just construct the sum of success. Essentially, let's do this by hashing. Add together all groups of 3 inputs. Add together the inputs in the pattern. Compare the moving sum against the input pattern. We probably won't get any false positives.
Even in the random test.
Probably. Like, there's not that many test cases here. Like, it's what, 20, 30 test cases? I'm not sure. Yes. And the sum of numbers that size is going to be, sum of 3 numbers that kind of size is going to be of order 50. So we only have about a 50% chance of randomly running into a false positive. And that way it works for arbitrarily long patterns. It just has a habit of getting false positives occasionally.
False and falso, yes.
I mean, we could probably come up with a better hash function.
Without multiplication, that's fairly hard.
Well, we've still got addition, so we could, like, add number to itself a few times, then add the next input number. That would at least shift them sideways a bit.
You could actually do an Adler hash. Accumulate the numbers into one accumulator and accumulate the successive sums of the successive values of the accumulator into the second one. So that one of them is counting a plus b plus c and the other one's counting a plus 2b plus 3c. Other way around. But
Wondering when I was time to the computer.
No,
That's
I
right,
can't
I'm
think of a
charging
good way
my
to do this.
phone.
I'm just going through and seeing if there is actually a point at which the sum of three successive values is 28. Don't think there is. Other than where it's really the correct answer. So you'd pass this test. Which is very tempting.
I probably should do it, but I'm enjoying not having to.
I don't know. I haven't had it very negative, but
That's a good reason to.
I just bored having
Menaced by an overlord. Not an overlord, Optimus.
very, very different. And also Overlord's actually never been down here. How did it go over? Not playing like a Supreme over there, that's not Overlord. He barely has Overlord.
Well, I probably can't tell the difference between Omega Supreme and Overlord.
This isn't the fact that you even know there is one called Overlord, which is what confuses me.
It's quite a memorable name. Okay, well, it's quite a memorable name if you know a tiny bit of World War II history, which is a mild interest of mine.
I repeat.
Right, okay. Here's the stupid implementation. Okay, it crashes immediately. Too many operands. Yes, that's not how you do add in this processor, is it? Right, that works pretty well. Let's see if it passes the random test, and if it doesn't, we'll need a better hash function. Oh! False positive!
Yes.
False sausages.
Because we have 3.10.19 and it feeds us a 10.19.3.
It was wise to your trick.
Ha!
If you accumulated the sum of the numbers and the sum of their squares and the sum of their cubes, then I think it would be impossible to.
Sadly, that requires multiplication. And we know how much code. And our useful multiplier requires like 2 stack memory nodes or something stupid.
It's true.
Good night, stream.
Good night, Mars.
Good.
Right, let's make our hash function slightly better. Of course, all this code assumes that the sequence is precisely 3 long, doesn't it? It's kind of stupid. I've carefully made this bit pattern length agnostic. But actually, all the other code depends. So we can probably make this even simpler if we just assume it's 3. Because then we just write the same code. Then this will be much simpler if we go via that processor. Because then I could use the same code for constructing the hash on both sides. Right, now I just need to tweak that bit of code until we get something that passes all the tests.
But at the moment you're expecting it to be the same as before.
No, I've added a couple more adds into the code in order to so it's now 4a plus 2b plus c or something like that. And yes, if that function fails, then, well, we clearly need something even cleverer. Success! And look at that instruction count. I'm quite alarmed by the fact that we're kind of pretty mediocre in terms of cycle count. But we are making 3 copies of every list, of every number, so...
So are you morally obliged to also do it properly?
I'm not sure. I mean, hashing is a perfectly good technique in general. It's just a bit dodgy that I will occasionally match incorrectly.
Yes, hashing is fine as a performance optimization, but it does want to be backed up with a now check it properly.
Yeah, the slight problem is it wasn't even terribly good for performance. Just slightly wondering if there's a convenient trick I can use for making it faster. Not really. I think my attitude is, let's see if it reasonably reliably passes the self-test. It seems pretty good.
Something occurs to me, do you get different cycle counts?
I think it takes the cycle count. Oh, right. Okay, there we go. Yes, right. I'll believe that this is not actually good enough. Because if I attempt to do 10 random runs...
There goes buzz on one of them.
We do still get a false positive.
It hadn't occurred to me before, but of course, yes. For many of these programs, the random test might have a different cycle count every time.
Yes, I think it takes the time it takes to run the first test.
Yes.
Right, okay, that is apparently not good enough. I mean, in the probability of failure is not low enough that I can just go, well, it's probably all right. It does look like the input things are always precisely 3 long, though. So, like, this is probably not going to be a very, very much more complicated program, now I come to think of it.
So,
we just rewrite this one to, or possibly with a bit of help from its neighbours, to repeatedly output the same 3 values, and then this one compares every value rather than grouping them together. And that will, I think, do it. So this actually can be quite simple, because this one just does every value it sees repeatedly. Oh no, it needs to do groups of 3. So yes, it
needs to remember the pattern so as to keep.
Yes. Well, I think this one remembers this one, possibly with some help, remembers the pattern, and it repeatedly outputs the pattern in order, and this one compares those values against the groups that come in from above, and sends 0 or 1 as necessary. making sure to discard the right number of inputs. But given that we're using all these processors anyway,
Get the one there, keep.
Okay, between estuary and the thingy on the same level. So that's a lot of buttons.
Right, good night.
that's not right. We need to send two values. This is a problem. I haven't got enough space to do all the things I want to do. Because I need N3 : MOV 1 down. That's all I need. MOV 0 down, sorry. Oh, no, I have a much better idea. Do I? Yes, let's split this into two processors. Right, how about that? Yeah. It crashed. Odd. You're trying to write downwards. You're trying to subtract leftwards. You're trying to mov from up. Why does that loop include a mov up ACK? That's of no use at all. Try that instead.
Yeah. I'd like to say every other cable except for the Ethernet cable on this laptop is quite hard to insert and remove from the socket. Except for the soldering power cable.
Right, so this one does not sneakily try to hash the incoming values. And instead, like, actually does the job properly. And it's still pretty decent in most respects. I mean, it still assumes that the incoming sequence, that the incoming pattern is always 3 elements long. But, like, as far as I can tell, it really is. Like, we've never yet seen one that wasn't 3. And this one does at least otherwise work reliably. I think it's kind of weird the way that this processor's idle time is so low. I suppose it has 3 instructions per value in the expanded sequence. And this one often has quite a lot fewer than 3, it's true. Well, we could try another one. The sequence gap interpolator. 3 dead nodes, but we get 2 stack memory nodes. What do you mean we're entangled? By using the TIS-100s, we may be becoming part of the universe they came from. Funny. It isn't funny at all. It sounds like not only is our world in danger, we may be partly caught up in some kind of liminal space between worlds as well. Funny. So, sequences are 0 terminated. Read a sequence from in. Sequence values are consecutive but unordered and are missing 1 value. Write the missing value to out. Ugh. So we receive, I think I may want to just go, oh god, this is far too difficult to do at this time of night. So yes, we get 78, 77, 74, 75, and we need to spot that that's missing 76. 50, 48, 47, and spot that it's missing 49, and so forth. And the sequences tend to be short, but of variable length. So, like, one approach is we insertion sort them into the stack memory nodes, and then yawn, and then find, and then once we reach the end of the sequence, run through the stack memory node, finding the gap that's bigger than 1.
Just check that I really did unset all my alarms for next week, so that I'm not going to hooray! I don't want to be randomly woken up first thing tomorrow morning.
So So we already have a sorter, albeit one that depends on a rather different layout of things. I think given that this one requires 2 nodes between the stacks, may not actually be very helpful to steal its code. Right, so yes. So in particular, when we first see our sequence, we won't know what the minimum or maximum value is. So it's quite difficult for us to, for instance, keep something that says, have we seen this value yet? Because we don't really know which values are going to be useful. So that kind of feels like we end up wanting to accumulate the entire sequence sorted before we try to do anything. Yeah, I'm yawning quite a lot. I don't think I can do this tonight. I'm just kind of pondering the shape of the solution. But that suggests that we want to try to do something like that last insertion sorter, only preferably not requiring 2 nodes between the stack memory nodes, because if we were to do that, it would probably need 3. And trying instead to do it all in this one. And then we have something like down here that reads out the final contents of the stack and finds the missing value. How would it do that then?
Good night, stream.
I think the way that it would do that would be... Oh no, that doesn't work. Possibly we'd need 2 nodes for that as well. Right, I think I'm going to say that this one is too hairy to try to do tonight, and I'm not going to even start, even though it's a bit earlier than I usually stop, because we have successfully written the character terminal, which turned out to be a bit slower than we'd expected, but it works. The back reference reifier, which was incredibly crude, but then nonetheless quite effective. And the dynamic pattern detector, which I turned out not to be able to cheat quite as well as I hoped. And so, yes. Oh, actually, it takes the worst of the three deterministic tests. Sneaky. Right, so I think that's enough for tonight, and we'll come back next week and try to sort out our sequence gap interpolator. Good night.